this did happen, it would have left some markers on this thing we call the cosmic microwave background. And doing this 9-year experiment, they were able to actually tease out this information and find the evidence of inflation.
A flashback to an earlier episode of Beyond the Sun. Jesse, welcome back.
Thank you.
What were you leading into there?
So there we were talking, that was last year in March.
Okay.
We were talking about this huge announcement from a group called the BICEP2 group, BICEP2 researchers. They have a telescope down in the South Pole, and they made this massive announcement last year saying that they found evidence of something called cosmic inflation. And just a quick primer on that, it's just this, this thing that we invoke, that we think that happened really, really early on in the universe, 10 to the minus 32 seconds after the universe started, really, really early, and this period of superluminal expansion where the universe expanded orders of magnitude in a really, really short time.
Is that the Big Bang thing?
It's part of the Big Bang theory, yeah. And this inflation idea explains a lot of really important things that we can't quite explain, like why the universe is the same temperature everywhere and how galaxies formed and things like this.
So while the temperature changes on Earth, it's the same in the universe?
If on the grandest of scales.
Okay.
Yeah, on the grandest of scales. And so this idea of inflation helps us understand that, but we haven't found any direct evidence of it yet. Last year in March, they announced that they did.
Okay.
Just fast forward to a week ago, and new evidence is showing that announcement that they made back in March is inconclusive. And so let me tell you what happened here is these gentlemen, this group from the telescope in South Pole, they were looking at the cosmic microwave background, which is how they figure out if this inflation was there. They're looking at microwaves, radio waves, basically. And they needed to take out the signal from dust in our Milky Way.
Okay.
Now, the best information at the time, back in March, allowed them to make a sort of a decent guess. Now, this is the most recent data that came from the Planck telescope, a different group of people that mapped the dust in our galaxy really, really well.
Is this data or a painting?
I know, it looks beautiful, doesn't it? This is actual data. This is actually the magnetic field of our galaxy, and it shows the polarization of light as a result of dust. The point is that this new data maps the dust in our galaxy the best. And then the BICEP2 group from last March, and this is the section of the sky that they were actually looking at, they had to go back and reanalyze their data based on this new information from the Planck telescope. And after they did that, they found that they couldn't make as significant a claim as they did back in March and had to retract their so-called discovery.
True scientists are willing to say, oops.
Exactly, and that's the take home from this. A lot of people would say, "Oh, it was a mistake. They should have gone public. They shouldn't have done anything like this." No, it's a window into how science actually works. They said, "This is our data. This is what we found," and then new data came out, and then they changed their idea based on the newest possible data.
Okay,
really great story.
All right. So where from now then? What happens next with that whole thing?
So now they're going to be we're going to have to look for different types of ways to pull out this polarization of light. Basically, we need stronger data. We need more people looking at the cosmic microwave background at higher resolutions. Basically,
it would have been a lot easier back then if they'd have left notes.
But good, yes.
They didn't. You've got some pictures of dwarf planets.
Yes, pictures of dwarf planets. So this is much, much closer to home. There's 2 spacecraft out flying through our solar system right now. One's called New Horizons and one called Dawn. We'll start with New Horizons. We've been talking about it a while now. It just came out of hibernation. It's on its way to Pluto. And look at this. This is its first image back from Pluto, the bigger spot, and Charon, the smaller spot, its largest moon.
The moon's called Charon?
Charon, C-H-A-R-O-N. I'm not quite sure how to pronounce it. Karen, you'd ask any astronomer, they all pronounce it differently.
All right.
So these are the 2 major bodies in that system. There's a few other moons around Pluto as well. And New Horizons is on its way there. It's been going there since 2006. And these are the first images we're getting back of actually being able to look at the planet bigger than a little dot. And it's showing that we're getting closer. Yeah. And in July, New Horizons is going to make its close approach. And this is a picture of Ceres, which is another dwarf planet closer to Earth, and Dawn is heading towards that dwarf planet right now, and it's got this really wonderful animated GIF. You can see the object actually spinning as it's approaching.
What's the difference between a planet and a dwarf planet?
That is a matter of definition. Back in 2006, the internet, in fact, before New Horizons launched towards Pluto, it was considered a planet, and then later that year it got reclassified to dwarf planet. And the difference is a bit of semantics and depends on who you talk to, but the definition is that in the orbit that object is in, it's the only dominant object. So for instance, in Earth's orbit, there's no major object around our orbit, it's just us. But with Ceres and with Pluto, there's other things of equal size, roughly, to Ceres and Pluto in those orbits, and so they reclassified those as dwarf planets.
All right, and also on the list, Jupiter is at opposition.
Yes.
This sounds like an astrology thing.
This is this is exactly what someone in astrology would talk about, is Jupiter moving through the sky.
That's not what you do.
Not at all. I'm an astronomer. Very different thing.
Yeah.
But this is when Jupiter's at opposition. That means that it's in the sky. From our point of view, it's exactly opposite the sun. So the sun is one direction, and exactly opposite is Jupiter. And that means that it's at its best possible viewing angle because it rises right at sunset. As the sun goes down, Jupiter comes up. And here in North America, it's going to be a wonderful time to go out and take a look at a planet. And there's a map of it right exactly where it is. You can see the moon's going to be going by. In fact, it's already passed it by. And you can go out and take a look at Jupiter. You can do this with just your eyes.
Yeah.
Don't need any telescopes.
Will it look like a big star?
It will look exactly like a star. The only difference is that it's really bright and it doesn't twinkle.
Okay.
And this is a really great image taken very recently. It shows 3 of Jupiter's moons crossing over top of the face of Jupiter, and you can see the shadows. Do you see the shadows of the moons there?
Yeah. It's not going to look like that when I look in the sky.
No, but if you had a decent telescope, like there's one at York University that you could take advantage of on Wednesday nights, and you could see shadows from moons just with a decent telescope.
Now, in Toronto, you could go to York University on a Wednesday night, and they'll let you look through the telescope.
Absolutely.
And is that available in other major cities across the country?
It depends on the city you're in and the university and their public outreach. But most universities that have a telescope have one night a week or one night a month that they make the telescope available. So if you're not in Toronto, there's probably a major university relatively nearby to you that would have ability to show you things like this.
All right, and how long will this be something?
So opposition, it shows up once a year as we get close to it, and then over the next few months, Jupiter's going to be fading in the sky. So it lasts a little while.
Okay, so it's not like you got to do it tonight, or
not at all,
or you're out of luck. And also, you have a chance of getting a clear night then.
Yes, right.
Yeah, I have about a minute left. You just mentioned it doesn't twinkle. Why do the stars twinkle?
So stars twinkle and planets don't.
Okay.
At least to our eye, and the reason for that is the size of the object and our atmosphere. So if you look through a planet or through a telescope at a planet, it's a shape, it's an actual circle. But if you look through a telescope at a star, it's still just a point source, it's a little dot. And as both of those beams of light go through our atmosphere, the turbulence in our atmosphere actually wiggles the light a little bit of the little tiny beam of light from the star, but the big beam of light from the planet can't be wiggled as easily because it's like a big spotlight.
So it's because of how close it is.
It's because of
the stars are actually bigger, aren't they?
They are much bigger. It's more that planets have a shape.
Okay.
And stars don't. Which also tells you that if you're in space, if you're an astronaut, there's no twinkling stars because you're above the atmosphere, which creates the twinkling.
All right. Good to see you.
Also known as scintillation, by the way.
Well, it's scintillating to do this segment every week. Thanks very much for being here.